वेलकम टू एनजीकॉन ऑनलाइन अकेडमी। इस लेक्चर में हम स्टार्ट करेंगे विद द डिस्कशन ऑफ संडे टेस्ट नंबर 6 which is second year test. The first MCQ says which is not a product of destructive distillation of coal. So coal की destructive distillation से we get 4 fractions: coke, coal tar, coal gas, and the fourth is ammonical liquor. So now water gas is not a component of destructive distillation of coal. Fischer-Tropsch process, a process of converting coal to petroleum, is represented by. So this equation has been taken from textbook. B is the correct equation, in which we use a combination of hydrogen and carbon monoxide and convert it into alkanes fraction, which is CnH2n plus 2, and along with that water is produced. Properties of organic compounds that are a cause of huge number of organic compounds. So first, carbon has a property of self linkage. कार्बन के साथ लिंक करके मिलियंस ऑफ कार्बन वाली लंबी चेन्स और रिंग्स बना सकता है, और फर्दर हमारे पास ऑर्गेनिक कंपाउंड्स के नंबर को मल्टीप्लाई करता है आइसोमेरिज्म का फिनोमिनन, जिसके अंदर हमें एक सेम मॉलिक्यूलर फार्मूला पे वेरियस डिफरेंट कंपाउंड्स मिल जाते हैं. तो बोथ ऑफ दीज फिनोमिना कंट्रीब्यूट टुवर्ड्स अ ग्रेट नंबर ऑफ ऑर्गेनिक कंपाउंड्स. Which of the given is not a heterocyclic compound? Pyridine is a heterocyclic compound. Its ring contains nitrogen. Cresol is not a heterocyclic compound. Its cycle contains all the carbons. And apart from carbon, it has OH and CH3 group, but they are not the part of the cycle. Therefore, it is aromatic compound, not a heterocyclic compound. Furane is oxygen containing heterocyclic compound, and thiopene is sulfur containing heterocyclic compound. The general formula is followed by, so this general formula CnH2n plus 1 whole twice CO. So this is basically carbonyl group, and along with carbonyl group, this is the formula of alkyl group. So it means that we have two alkyl groups, which is represented by CnH2n plus 1 2, and in between there is a carbonyl group. So this is a formula of ketones. Two different classes of organic chemistry having same general formula show. So if there are two different classes, like we have alkenes, they are CnH2n, and we have cycloalkanes, they are again CnH2n. So if the classes are different but their general formula is same, so they are functional group isomers of each other. The precise definition of organic chemistry is, so the precise definition of organic chemistry is that it is the study of hydrocarbons and their derivatives, which is not a characteristic of homologous series. So homologous series has same general formula. This is correct because all the compounds of homologous series belong to same class of compounds. Similar reactivity is correct. Same physical properties is incorrect. In a homologous series, all the members follow a trend in physical properties. All their physical properties are not same, but they do follow a regular trend. Which of the following functional group are deactivating and not orthoparadirecting? Deactivating and not orthoparadirecting means metadirecting. So COR is deactivating and metadirecting. Which is the functional group of amides? So amides are basically derivatives of carboxylic acids. Their functional group is aminocarbonyl, which is CONH2. A class of compounds represented by general formula CnH2n, where n is greater than 2. So CnH2n is the general formula for alkenes as well as cycloalkanes. Now the smallest alkene starts from 2 carbons. and the smallest cycloalkane starts from 3 carbons. So if we talk about CnH2n where n is greater than 2, then we are talking about cycloalkanes. Correct IUPAC name for the compound. So let's open the chain. Then we have CH, along with it we have another CH, and with this we have two CH3 groups like this, and then we have CH2 CH3. Now here two longest chains are possible, but we choose that longest chain which gives the greater number of substituents. We number from where the first substituent is closer. So this is 3-ethyl, 2-methyl and pentane. So B is the correct option. Single bond of alkanes is rotatable, giving rise to. So alkanes can rotate over their single bond and they give rise to a type of isomers which are called conformational isomers. Ring opening reactions are most easily given by. So ring opening reactions are given by cycloalkanes. In cycloalkanes, the greatest angle strain is present in cyclopropane, so it gives the ring opening reactions most easily due to angle strain. The other cycloalkane that gives ring opening reaction is cyclobutane, but it requires drastic conditions to give ring opening reactions. So cyclopropane easily gives ring opening reactions. In halogenation of alkanes by free radical, termination step can be represented by. So in free radical mechanism, termination is any step which involves combination of two radicals to give us a neutral molecule. So whenever two radicals combine and give us a neutral molecule, that step is called termination. In all the given steps, two radicals are combining and giving us neutral molecules, so all of them can be termination steps. In presence of excess chlorine, major product formed as a result of chlorination of methane. So whenever methane is less in amount and chlorine is in excess of amount, so each of the chlorine atoms will replace the each hydrogen of methane, and tetrahalomethane will be our major product. Dehydrohalogenation of alkyl halide is carried out in the presence of. So alkyl halides are dehydrohalogenated in order to give us alkene. So HX is removed, and for that purpose we use alcoholic KOH. Aqueous KOH is not used because aqueous KOH will not carry out elimination, but the OH of aqueous KOH will substitute halogen to give us alcohol. Therefore we use alcoholic KOH in order to ensure that instead of substitution, elimination occurs and gives us alkene as the end product. CnH2n minus 2 is the general formula of, so this is the general formula of alkynes. Position isomerism can be exhibited by. So first is dichloroethane. So dichloroethane can show position isomerism because there can be two position isomers, one 1-dichloroethane and one 2-dichloroethane. Same is the case for ethylene glycol. It can be 1,1-dihydroxyethane or 1,2-dihydroxyethane. Propanol contains 3 carbons and along with it, it contains OH. So OH can be present at first group giving us 1 propanol, or it can be present at second group giving us 2 propanol. So all of them can show positional isomerism. Geometrical isomerism is possible in. So symmetrical butene is basically the name of 2-butene which contains 2 CH3 groups. So 2-butene can show geometrical isomerism. It can either exist in the cis form or in the trans form. Optical isomerism is not shown by. So lactic acid is alpha hydroxypropanoic acid. So it contains a chiral carbon which has 4 different groups attached to it, so it gives optical isomerism. Isopropanol is alcohol in which we have OH group attached to second carbon. So here this carbon does not have 4 different groups, so it does not give optical isomerism. functional group isomer of propanol is, so propanol contains 3 carbons and along with it, it contains 8 hydrogens and 1 oxygen. So functional group isomers of alcohols are ethers. So methyl ether, which contains 3 carbons, 8 hydrogens and 1 oxygen, can be functional group of the isomer of this compound. So methoxyethane is the functional group isomer of propanol. True about the conjugation in 1,3-butadiene. So if we see the 1,3-butadiene, in 1,3-butadiene there are 2 double bonds. So here for one double bond the bond length should be 134 and for one single bond it should be 154. But due to conjugation the double bond is distributed all over the carbons, which makes the double bond increase in length. So double bond increases in size and from 137 it moves on to 138, and this single bond decreases in length due to distribution of double bond, and from 154 it becomes 147. So carbon-carbon double bond length becomes longer and carbon-carbon single bond length becomes shorter. So C is the correct option. Carbon-carbon single bond length of propane is, so in propane carbon-carbon single bond length is 154 picometers. But here the question is for propene. So in propene, if we see carbon-carbon single bond, this carbon is sp2 hybridized and this carbon is sp3 hybridized. So due to sp2 sp3 overlap, the bond length is a bit shorter than 154 picometer. Factors that do not stabilize an alkene. More branching, so the more branching present, the more alkene is stable. More alkyl groups also stabilize alkene. Conjugation also stabilizes alkene. Consecutive double bonds make alkene cumulated, and cumulated alkenes are less stable, so this factor does not stabilize an alkene. Fifth member of alkene family is, so first member is ethene, which contains 2 carbons. So fifth member should contain 6 carbons, so it is hexene. So B is the correct option. Species in search of positive charge are called. So species that are in search of positive charge, they are called positive lovers. So positive lovers are basically nucleophiles. Tertiary alcohols follow dash, while primary alcohols follow dash mechanism of dehydrohalogenation. So dehydrohalogenation is basically an elimination reaction. So in elimination reactions, tertiary alcohols follow E1 while primary follow E2. So B is the correct option. Alkyl halides undergo. So alkyl halides are these compounds. They undergo nucleophilic substitution with halogen. So their characteristic reactions are nucleophilic substitution reactions. Ozonolysis of 2-methyl-2-butene gives. So this is 2-butene and here we have methyl group. So this group separates and give us a 3-carbon ketone, which is acetone, and this group separates and give us a 2-carbon aldehyde, which is acetaldehyde. So acetaldehyde and acetone are the products. A more stable alkyne of the given. So alkynes which contain more alkyl groups along with the triple bonded carbon are more stable. So here if we have 2 alkyl groups, such alkyne is most stable. So in 2-butene we have 2 CH3 groups here, so this alkyne is more stable. Alkyne having pH lesser than others. So pH would be lesser for that alkyne which is acidic. So terminal or 1 alkynes are basically acidic. Among all of the given, propyne is a terminal alkyne, so it is acidic and has lesser pH. Dehalogenation of dash yields alkenes. So alkenes are prepared by dehalogenation of vicinal dihalides, while same process done with dash gives alkynes. So for alkynes, we dehalogenate tetrahalides. So in order to prepare alkynes, we remove halogens from tetrahalide. So vicinal dihalide gives alkene and dehalogenation of tetrahalides give us alkynes. Propyne on hydration forms an unsaturated alcohol which tautomerizes too. So this is propyne. When we add water to it, it follows Markovnikov's rule, and according to Markovnikov's rule, this compound is produced. So this compound is propene 2-ol. So this propene 2-ol tautomerizes to acetone. So acetone is the end product of hydration of propyne. If an unsaturated compound double and triple bond occur at the same position, so for this the IUPAC rule is, if double and triple bond occur at the same position, the first preference is given to double bond and the second preference is given to triple bond. So in the name we add "-ine" first and then comes the "-ine", so the name ends in "-ine". Ozonolysis of alkynes gives 2-carboxylic acid via the formation of. So whenever we ozonolize an alkyne, before the last product we get a dialdehyde or a dicarbonyl compound, which in the ends gives us 2-carboxylic acid. So it gives us 2-carboxylic acid via the formation of dicarbonyl compound. C6H5NH2 is called. So this is phenyl group which is C6H5, and along with it if we attach NH2, so such compound is called aniline. Paraxylene is also called. So paraxylene is this compound in which one CH3 is attached to the main position and other is attached to this position. So it is called 1,4-dimethyl benzene. Cyclohexane is stable than benzene by amount of. So whenever we hydrogenate benzene, we add 3 hydrogens to benzene. Benzene converts into cyclohexane. So the heat of hydrogenation of benzene is -208 kJ per mole, which means that benzene releases 208 amount of heat in order to give us cyclohexane. Therefore, cyclohexane is stabler than benzene by an amount of 208 kJ per mole. True about intermediate arenium ion formed in the electrophilic substitution of benzene. So this is the arenium ion which is formed in electrophilic substitution of benzene. It is stable? No, it is unstable because it has a positive charge. It has 3 pi bonds? No, one of the pi bonds gets broken. It is non-aromatic? This is correct because this compound has 1 double bond missing, which makes it non-aromatic, so it is a non-aromatic compound. Nitration of toluene with dilute HNO3 gives mixture of products dominated by. So if we nitrate the toluene, so due to large size of NO2 group, the CH3 group, the NO2 prefers not to attack ortho position, but it preferably attacks the para position. So para-nitrotoluene is the major product. Acylation of toluene with acetyl chloride gives. So with acetyl chloride, acetyl group attaches to the benzene ring and it gives us acetophenone. But if toluene is present, so this acetyl group is very large in size, it prefers to come at para position rather than ortho positions. So the major product is para-methyl acetophenone. Hybridization in benzene is, so benzene has 6 carbons, all of them are involved in double bond formation, so hybridization is sp2. Fastest nitration is observed in the case of, so among all of them phenol has OH group. Now this OH group is a very strong activator of benzene, So fastest nitration is given by phenol. Moderate deactivating group of the given is. So moderate deactivating groups are those groups which contain unsymmetrical multiple bonds. So unsymmetrical multiple bonded groups are basically those groups which contain double or triple bond between two different atoms. So this aldehyde group, which is formyl group, it contains double bond between two different atoms, so it is moderate deactivating. Chlorine is weakly deactivating and these two are strong deactivating. Alkyl halide with higher boiling point. So among halides, the order of boiling point is fluorides are the least and iodides are greatest. Although these compounds are polar, but their major forces are London forces due to their large size. So London forces are stronger than in iodides, so iodides have greatest boiling point. Which reaction for preparation of alkyl halide leads least drastic conditions? So if we prepare alkyl halides are easiest to prepare from iodides. So iodide is easiest to prepare, and if we are preparing iodide from a secondary alcohol, secondary alcohols are more reactive than all these primary alcohols. Therefore, it is easiest to prepare isopropanol from HI. Role of pyridine in preparation of alkyl halide from alcohol and SOCl2. So if we use alcohol plus thionyl chloride, so here we get HCl, SO2 and alkyl chloride. So in this reaction we use pyridine not as a catalyst but to act as a solvent. So pyridine acts as a solvent. It is a base, therefore it absorbs HCl. So all of them are roles of pyridine. Alkyl iodides are most reactive halides due to. So alkyl iodides are most reactive because this bond is weakest and it is easier to break this bond in order to attach nucleophile to alkyl group. So C is the correct option. Characteristics of SN2 reaction is. So SN2 reaction follows 100% inversion of configuration, because in SN2 reaction the nucleophile attacks in a single step, so it always attacks from the back and is attached to the back side from where the nucleophile was the leaving group was leaving. The nucleophile always attaches to back side of it, so 100% inversion is achieved. Most reactive alkyl halide in bimolecular reaction. Bimolecular reaction mean either SN2 or E2. In such reactions, the order of reactivity is primary, followed by secondary, followed by tertiary. So in primary, we have ethyl iodide and propyl chloride. Now we have to choose one of them. So we know that among alkyl halides, iodides are most reactive, followed by bromides, followed by chlorides, and then we have fluorides. So iodides are most reactive, so this is the correct option. True about reactions of alkyl halides. Unimolecular reactions share same first step. This is correct because unimolecular reactions are SN1 and E1. They follow the same step in which an alkyl halide molecule loses its halogen atom and gets converted into carbocation. So this step is same in both of these reactions. Strongest nucleophile to attack. So in all of these, the order of reactivity is NH2 is the strongest nucleophile, followed by OH, then we have bromide, and then neutral nucleophile H2O. So NH2 is the strongest nucleophile. Strong nucleophile primary substrate and polar aprotic solvent favors. So when nucleophile is stronger, it will prefer to attack the alpha carbon rather than beta hydrogen. So first we establish that strong nucleophile favors substitution over elimination. Now if the substrate is primary, so primary substrates favor bimolecular reactions. So it means that SN2 reactions are favored, and polar aprotic solvent also favors SN2 reaction. So B is the correct option. So that's all for this test. Thank you.